Nice. Okay, read that to me and then I'll think about it.
So, water is poured into a container in the shape of a right circular cone with radius 4 feet and height 16 feet. Express the volume of the water in the cone as a function of the height h of the water.
Okay, guys, I'm gonna make a quick sketch to try to illustrate what he's given me to work with. Let's say it has something that looks like this. And he says, Professor, it's supposed to look more like a cone. Let's make it look like this. This. Jonathan, I think you said this cone, we're supposed to pump water into it.
It says water is poured into a container, yeah, in the shape of a right circular cone with radius 4 feet.
Okay, radius 4 feet, you put that in different colors things in. Guys, so the radius of the cone itself, here, mark this up, this thing up. He's telling me that's radius of R, oh no, you said 4 feet.
Radius 4 feet.
Beautiful, that's 4. And what was the height?
The height was 16 feet.
So we're gonna mark that like this. That'll make some sense of it. The guys got water coming in, and this is given to me as those dimensions. A radius of 4, a height of 16 for the cone. Now water's being pumped in. Now when I do teach calculus, you don't have to worry about this right now, but I'm gonna tell you what's gonna happen when they revisit this in Calc Math 7. If they do, which I think most instructors do. They're also gonna tell you all of a sudden in Math 7 that there's a hole there in the bottom of the cone. So as the water's being pumped in, water's gonna be leaking out. And you gotta come up with, and they'll tell you at what rate the water's coming in, which we don't need here on Math 2 problem. What rate the water's being pumped in, and what rate it's leaking out. And then we'll relate those rates, and then ask you a few questions. Okay, right now though, we just have what we have there. Now, Jonathan, what are they, I've got the sketch for me. What are they asking me to do?
Express the volume of the water in the cone as a function of the height h of the water.
Okay, now hang on, water. So this thing is filling up. Let me erase my 16 here you gave me, right here. Let me just show the water level. So this thing is filling up with water. Which makes sense. As you pour water into it, you're pumping water into it, water height is rising. Now, does anyone think they know what the volume standard formula, some students do, some students don't? What a volume formula is for a cone?
Pi r squared times h over 3.
Okay, that's right, like this, I got you. So the volume, which I will give you, you see one of these ever on a quiz or a test, I will give it to you, I'm gonna write mine like that. 1/3 pi r squared h. You have enough to memorize as it is, so I'll give the formulas to you. That's the volume formula for a cone, okay? By the way, did we do a box last time, did we?
Yes.
And the volume formula for a cone is this. The volume formula for a box was what last week? Length times width times height. That's the easiest. Guys, with that said, Jonathan, read that last part to me one more time.
So it says, express the volume of the water in the cone as a function of the height h of the water.
In other words, find this. Find the volume in terms of only h, the height of the water. Now, I'm going to do things on the schedule shortly. So guys, right now, you say, Professor, there's the volume right there. No, they want this rewritten in terms of h only. So that r has got to go. They do not want the r in the formula for some reason. Now I'm going to adjust this a little bit. I see the height, the water coming in. I've got the water here. Guys, I'm going to do this. I'm going to show that the height of the water, let's say, something like this. piece here and look at this, and let this represent H, that represents the height of the water. And this little piece here, the radius of the water. So as the water's coming in, it's filling up, so this represents at some moment the height of the water, and this represents the radius. Now, if someone's clever, and someone may have looked at this problem over the weekend, does anyone see anything at all in that sketch? And let me even do this to give you a better hint. Let me label this, just give you a better hint. In capital letters, say, I got A, B, C, D, E, C. I marked those for a reason. Does anyone see anything in my little sketch up here that maybe I could on the side here say something about A, B, C, which is a triangle. And then underneath it, the water level, D, E, C, that's an E right here, guys, if you can't see it. D, E, C, that's another little triangle. There's two triangles involved here. Does anyone see anything at all? Something between those two triangles I could say. I got a large one, of course, and I got a small one.
The ratio of height and radius is the same.
Okay, let me ask you first though. Are the two, I'm gonna use some vocabulary. Are the two triangles congruent? If you remember what congruent means. No. They're not congruent. Does anyone remember what congruent triangles were back in geometry? They're the ones that have the same size and same shape. They have the same size, same shape. If they are congruent. There's another word here. These two are not congruent, but there's something else, and I need the vocabulary word from geometry. What are they? Similar in shape. They are similar in shape. They're not congruent, they're not the same triangles, but they are similar. Now guys, if I pull this out and say, okay, triangle ABC, the large one, ABC, and the word symbol they use for similar, I think most textbooks uses that, is similar to triangle DEC, like this. Those two triangles, the big one and the little one and the blue down here, are similar triangles. Now, I think one of my students is telling me, Eric, I think you're telling me. He says, Professor, I remember if they're similar, there's something going on between the sides. The sides aren't equal when you compare the two triangles. They're not equal sides there involved. But there's something else going on. Does anyone recall if they're similar, what's going on between the sides when I start matching up the sides? Anyone? Eric, and I think you were telling me in essence what was going on.
Same ratio of height.
There's a ratio. So if I start comparing side to side, side to side, so in other words, I'm gonna compare, guys, this 4 he gave me. This is one side of that large triangle. So we'll compare it to, on the side here, let me do a ratio. 4 is to, and what's acting as 4 on the smaller one?
H.
Not H. What? R. 4 is to R. As, let's go back to the large one. The large one was, I think he gave me the height, I erased it. I think it was 16. What is the height of the larger triangle? 16.
Yes.
And that is to be compared to what? For the smaller triangle, what's acting as its height? Down here. It's at the H that I have. So all I'm doing is just match up sides in like a ratio, a proportion. So this side of the large, 4 is to R, as 16 is to H. Just match up the radius of each one, the height of each one. And now I have a proportion to work with. Now, keep in mind what they want. They're saying, please rewrite this volume for me, which I'll give to you. But rewrite it and have only an H in it. They want V of H only, no R's. Now, can anyone be clever and tell me how on earth am I going to make that go away? They do not want an R in the formula. They want just V of H. You don't have an idea.
You maybe start by pulling out an R,
So again,
or no, backing out an R.
down here,
Oh, down there you could just cross multiply.
Could I solve for R down here?
Yeah.
Now, if I get R all by itself and solve for R, then I take that back and substitute R with that. And if I do go down to step 2, guys, we'll probably solve for R. Right here, so I'm doing the notes there. Solve for R. Here we go. I'm gonna do a quick cross multiplication or a common denominator. It's up to you guys. We have 16R is equal to 4H. Quick cross multiplication or common denominator. Divide by 16. I'd like to solve for the R. 16's cancel. And we end up with 4H over 16. I know 4 over 16 from math is 1/4 reduced down, looks better. So there's R is equal to 1/4 H. Now why did I do that in step 2? What am I gonna do now, guys? I'm gonna take that back and substitute it, look at this, into my standard formula for R. And I go back and rewrite with that substitution, my original, then I'm gonna have this, 1/3 pi, and here it goes. In place of R is 1/4 H. Put it in like this. And of course, that's being squared times H. All I did was change this formula. All in terms of H now. I'm not worried about the pi. Pi's a constant. It's those variables. Guys, everything in terms of H now? That's what they want. They want V of H, which I do have. I can clean it up some, of course. So if I clean this up, make it look better, 1/3 pi. This is 1/16. In fact, the H's, H squared times H will give me H cubed. I can do that and clean it up. Better yet, I could multiply my numbers. Let me group those numbers. I got a 1/3 and a 1/16. Let me group those together so you can see it. And I got a pi H cubed. Let's clean this up. That's what, 1/48 pi H cubed. And that's what we were looking for a final answer. Jonathan, do me a favor, read that last statement to me again. What were they asking me to find? Let's make sure I've got it.
Yeah, so, express the volume of the water in the cone as a function of the height H of the water.
And this is only in terms of H now. That's what they want. So now I have the volume formula in terms of H. Yes?
3 plus pi.
No, pi's a constant, 3.14, you can't touch it. The H and the R, those are variables. You can touch those. Guys, that make sense? We take something and substitute in to make it look the way we want it to look? Absolutely. Okay. Let me do this before I leave it. On the side here, suppose I say just that I've got the radius to be a 4 he gave me, the height of the cone was 16 originally, right?
Yep.
If you take those original numbers given to you, radius is 4, height is 16, and I ask you, what's the volume of the cone when it's completely full of water? How much water is in that cone when it's completely full? What would you do with that given volume formula? What would you do to find how much water, cubic feet, cubic inches of water is in that cone when it's completely full? And this is a little check here. What would you do?
Multiply pi by 1/48 and then multiply that.
Well, something else too. Let's go back to the original first. I'm gonna do the original first. 1/3, that was the standard formula, pi. Now what was the radius? 4, so I'm gonna put a 4 in there. And the height, I think, was a 16. If I plug those in directly that he gave me, that tells me how much water is inside that cone when it's finally full of water. And if I clean this up, guys, this is 1/3 pi. Looks like it's 16 times 16, I guess. Okay, 1/3 pi, 16 times 16. Does anyone know what 16 times 16 is?
256.
How much?
256.
256? So this would be 256 pi, like this, over 3 cubic units. Let's say this is feet. 256 pi, and I'm not going to ask you to multiply pi times that. Just do it like that, 256 pi over 3 pi, 256 pi over 3 cubic units. That's how much that cone would hold. Now suppose the student says no, and Eric, I think you're telling me this, Professor, why not go to this formula and find it? You just did the formula, you just redid the formula, and now you have in the height, if you just use that height formula, we say 1 here, now to find the answer, 1 over 48 pi, and guys, when it's completely full, all I need to worry about in this new version is the h. And what was the h if it's completely full? 16. And guys, if I do this, help me out here, volume of which this is being cubed. You got 1 over 48 pi, I hope this works out, 16 cubed, oh boy, 16 times 16 times 16. I know 16 times 16 is 256, we got that earlier. Let me do it like this, 16 times 16 times 16. I'm trying to avoid all this math. That's 16 cubed. Is that true? Just trying to avoid some math. Could I cancel one of these 16s into 48, call it a 3? Just to save myself a little time. And if I do, am I left with, for the volume, using this new formula, am I left with 16 times 16, which I think Eric gave me to be 256 pi over 3. So is that formula will give you the same answer as the original formula? You guys should go check that and see if they give me the same answer.
It does.
It does?
Yeah, down to the decimal.
Same answer. Okay. I'm not going to do this, guys. Suppose they had asked me to find the volume with reference to the radius, find V of R. Now rewrite the formula, but have only R in it, no H. Could we do it somewhat like I did mine with the H? Absolutely could. Maybe awkward, but you could get in terms of R here. Guys, that's all I want to do on that handout. I just did that one problem. I realized there was another problem on there. But the one I wanted to look at today with you was this cone problem. Okay? Now, if you can get through, which we've done, if you get through the introduction to this course, I've always told all my classes this. That's that first week we did last week. If you can get through that, do well in this first test, I, as an instructor, I think the rest of this course will fall right into place for you. It's that first week that's tough. Because all of a sudden this textbook jumps into solving all these different types of equations, inequalities, what a difference quotient. My goodness, we did transformations, all those different topics. Pretty soon, chapter 2, they start slowing down. And consistent, just talk about one topic for a while. They don't just jump around like I did in week number 1. That's the way the textbook